Alright, now we move to our estimation part. Okay, here. In this stage, what we have is only data, which are x and y. So, right. So then the first step is to calculate OLS estimates. Right. We have the formula x prime x inverse x prime y. So, right. Let me say beta hat equals x prime x inverse, then x prime times x inverse, which is I and v, times x prime times y. Okay, so this is OLS estimate, right? Just to make sure this is correct, let me save it and run this code here. Still no error, and I want to see the values of the beta hat. Yeah, beta hat must be what? 2 by 1 vector here. The 0.1, 0.9, which are close to true values. Of course, these numbers must be different from the values shown in your computer. Okay, because we have different, the students have different covariance and error terms. So U and have a different x and y here. Just to make sure we have the same outputs, let me say R and G. See 1, 2, 3. Later I'm going to explain what this is later. Okay, whenever we have chance. Here. And let me run this without semicolon here. Now you see that these values are fixed, but without this line, okay, without this line, you will see different estimates, okay, every time, right? Okay, so once we have this line, we have the same random samples. That's why we have the same x and y. So that's why we have the same OLS estimates. Okay, let me run it again. Then you should have these values in beta hat. Otherwise, there must be an error in your code. Okay, so this is the OLS estimates. Then what's the second step? The second step is what? Second step is to compute the residuals. Let me name the residuals as E hat. E hat equals y minus x times beta hat. Okay. Semicolon. Then this is residuals. This is OLS estimates. Okay. Right. Then what's the next step? The next step is what? Variance estimates. Sigma square hat, right? E hat prime E hat divided by cap T by 2, right? So then sig 2 hat is E hat transpose times E hat divided by cap T minus 2 semicolon. So this is variance estimates. Right. Okay. Before I forget, please make sure that the metric distinguish capital and lower cases. So small e and capital E are different names. Okay. Here, this small e though. What's next? So next is what? Variance of beta hat. So then variance of beta hat. Okay, sig 2 hat times what? Inverse x prime times x, right? So this is variance covariance of beta hat. What's the dimension? Dimension must be 2 by 2, right? 2 by 2. The next step is to compute standard errors of beta hat. And to do this, we are going to take diagonal elements from the beta hat, variance of beta hat, then take square root, right? So then standard error, of course, diarc, variance of beta hat. Then we are going to take a square root, SQRT. Okay. Right. So what's the dimension? Now this is 2 by 1. 2 by 1. Okay. 2 by 1. So this is standard error of beta hat. This is 2 by 1 vector. The final step is what? To compute t statistics, beta hat divided by standard errors of beta hat, right? Okay, so then t values, beta hat divided by standard error, right? Okay, let's take a look at this. Okay, what's the dimension of beta hat? Beta hat is 2 by 1 and this is 2 by 1. So then is it possible to divide 2 by 1 vector by 2 by 1? No, because again this is basically matrix algebra. This is not possible. So then this is what? This is, should be element by elements operation. So in this case we will use dot division. Then dot division means element by element operation. Then also you can see the dot times, right? Dot star. Then element by element multiplication, right? So then in this case we have the dot division, dot slash. So then it's possible. Okay. Okay. So then let's run this without this dot. Then you will see an error message. Right. You see this error message, right? Dimensions doesn't match. Right. So then we have to put dot and run it again. Oh. Where is the problem? Here is the problem. Okay, here is beta, not beta hat transpose. Okay, there is no point to have transpose here. Just x times beta hat. Okay, here run it without dot. That's weird. Why it runs? It's okay in this new version. Okay, let me see. SE t values. Beta hat. T values. No, right. This is error. The t values must be 2 by 1. Right? T values must be 2 by 1. 2 by 1. So then let me put dot. Okay, and now t values. Yes, we have 2 by 1 vector. Run it again. Oh, let's see t values. Okay, yes. Okay, you should get these numbers as well. Okay, because we are using the same command here, rng. Okay, of course if you try with different numbers, not 1 2 3, say 1 4 4 whatever. Okay, so then you will see these t values. Okay, you should have these values once you have this number 1 4 4, right? Okay, right. Okay. Right. So this is the OLS estimation simulation using MATLAB. Please try the second stage.